Welcome back, my dear friends and my students. Today, the new concept that we are going to discuss about briefly. Are energy and work the same thing? Energy and work are they same? Are energy and power the same thing? Energy and power. So here today we are going to discuss about work, energy and power. So let's discuss a short discussion about what is energy. Ability to do work, that's all. And what is work? You apply a force on any object so it displays from one point to another point. Here is a diagram. Now we are discussing about work and we connect it to the energy, and later we see if it is same or not. Here is a box and I want to displace the box from the point 1 to the point 2. So I need to apply a force. So here a force is a factor which affects the work, right? What is another factor? It moves from the point 1 to the point 2. So this movement is called distance or displacement. Distance and displacement, the better word is displacement. It is because it is moving in a straight line. If any object which is moving in a straight line, the path covered, the total distance covered, the length covered is known as displacement. So if there is a force, there will be a displacement because the object will go in a straight line. Okay, it's a second factor. So two factors we have learned today. One is a force, another is displacement. Two factors are therefore work done. These two factors will affect the work that you have to do. If you apply, for example, 50 Newton and the object is moved 2 meter, so what is the work done? So we need to know the formula, right? The formula is here, force multiplied by displacement. And what is force? 50 Newton. Newton is known as a unit of force. The meter is known as unit of distance and displacement. Okay. There are lots of units. Centimeter is a distance, millimeter, meter, kilometer, micrometer, nanometer. Lots of meters are there. And in this example, we have taken as a meter for the displacement. And you multiply the two numbers. 50 multiplied by 2 is 100 Newton meter. This is the total unit for the work. So Newton, it comes from the force. Meter, it comes from the displacement. Okay, now 100 joules, because Newton meter equal to joules. So if you do any problem, any calculation for work, the final unit you can write either Newton meter or you can write joules. Okay, now we can have another discussion. If you apply 100 Newton force, will the displacement be the same, small or big? It will be big, of course, right? So if it is the same box, the condition, if it is the same box, the same weight, and you apply more force, it displays more and you are doing more work. So if you want to increase your work, you have to apply more force. That's all, right? Okay, so what are the two factors that affects the work? Force, another factor, displacement. So what is the unit? Newton meter, another unit joules. Okay, Now here is the application. What is application? How we are applying it? Now we are applying it. The first question I asked, are they same? Yeah, they are same. That means if you are doing 100 joules of work, which means you are releasing 100 joules of energy. If you don't have 100 joules of energy in your body, you cannot do 100 joules of work. So it is very important that you should have 100 joules of energy in your body. Okay. So another example, when you ride bicycle, example, to you ride a bicycle, you need an energy. If you want to ride a bicycle, you need energy. What kind of energy? So you eat food. So how do you get your food? You intake chemical energy to transfer your energy to ride a bicycle, isn't it? So if you want to ride a bicycle, you have to eat something, some food, so that you gain energy. You gain energy. What kind of energy you gain? Chemical energy. So if you transfer more energy, you do more work. If you transfer more energy, so you can do more work. So you can displace more. That means you can go very far, more distance you can cover, you can travel. Another example, construction workers transfer cement sack, sand and many more objects to the top of the building by climbing stairs. As they climb many floors, they need more energy, right? If they have energy, they can do work. That's what I am telling. If you have energy, you can do work. So they are interrelated, they are equal. So the work depends on energy. Work done is equal to energy transferred. Transferred means you are transferring your energy. How you are transferring energy? The last example I told you, if you intake chemical, you can ride a bicycle. So the chemical energy is converted here, in this case kinetic energy. Kinetic in physics term, this is called movement, moving energy. If you run faster, you will be having kinetic energy. If you run slower, a less kinetic energy, right? If you stay, you are not changing your position, you are not moving, zero kinetic energy. So energy transferred is equal to work done. If you transfer 1000 joules of energy, which means you can do 1000 joules of work. So work and energy is measured in the same unit. So work done joules, and for the energy also in joules. So work done is a unit of work done joules, and then unit of energy joules. What is the spelling of joule? Joules. Okay. Next, another example. Many types of energy we have, and then we discuss a few of them. If you eat food, you have chemical energy, right? Okay, what are the other chemical energy you can find in the daily life? The petrol, battery, candle, and many more objects where they have chemical energy. Another example, if you run, what kind of energy you have? Already I told you, right? Kinetic energy. So don't forget, my dear students and my friends, movement always related to what? Kinetic energy. So if you want to move, you should have energy, chemical energy. So you eat well. Boost is the secret of my energy. That means he gets chemical energy, he eats chemical, and he transfer his energy so that he can move, walk, so he can do a work. Next, moving car, flying birds, flowing water, running athlete has kinetic energy. They are all having kinetic energy. Okay. Next example. Now, if you climb mountain, you do some work against the force of the gravity. If you are doing some work against the gravity when you are moving up, you are climbing stairs, you do every step you do work against the gravity, because the gravity is pulling you downwards. Every time the gravity is pulling you downwards, so you are moving upwards, that means you are doing some work against the gravity, right? So you will be storing some energy in your body, that is called gravitational potential energy. If you are on the fifth floor and you would have 5000 joules. If you go to 10th floor, if you go to the double the floors, that means if you are in the 10th floor, how much would be the GPE? Just it is doubled, that is 10,000 joules. Is that clear? That means what you understand here about the gravitational potential energy, in short we say GPE, gravitational potential energy. Height increases, gravitational potential energy increases, because every time you do some work against gravity. So don't forget, against gravity you are doing work, so you are saving, you are increasing your energy that will be stored in your body, that is in the form of gravitational potential energy. So the work done is here is equal to gravitational potential energy, because you are moving against the gravity, so you will be developing gravitational potential energy. Next application: eat more food, you gain more chemical energy. Climb more, you gain gravitational potential energy. Run faster, you gain more kinetic energy, right? Okay, some other facts. Now we are connecting the energy and power. So many of us, we think both of them are same. I have more energy, so I have more power, right? So here we have some discussion so that it would be more clear for you. It is not the same. Energy is not same as power. Okay, here example: if you do work faster, it will not affect your energy. Okay, but it will affect your power. So faster in the sense the time. If you take more time to do the same work, you have less power. Okay, if time is less, more power, the power is more. That means example, here example is given: Mikhail and Marwan runs up to the first floor having equal weight. Mikhail weight is 100 Newton, Marwan weight is 100 Newton. Example: weight we measure in Newton, and later we can discuss about what is weight and mass. Okay, okay, for you an example: 50 kilogram mass, and Marwan also 50 kilogram. Both of them are having the same mass or the same weight. Okay, next, Mikhail has he takes 5 seconds, Marwan takes 10 seconds to reach the first floor. Do they do the different work? No, they are doing the same work, because they reach the first floor. Both of them are covering the same distance, means same height. So their work done and their energy are equal. They do the same work because both of them travel the same height and they are all equal in weight. What is the difference? Mikhail has more power than The difference is Mikhail has more power than Marwan. It is because Mikhail takes only 5 seconds, time less, more power. As you decrease the time, you will be having more power. And this is the question for you to think: how can you find your own power? Okay, now you can just think, how can you find your own power? If you want to write about this concept, you have to tell how can you find the work, how can you find the time. I give you some formula for you. If you want to find your own power, you have to find your energy and you divide it by time. And you know that energy is equal to work, and find your work and divided by time. And you know what is work done, you can find it easily: the force multiplied by distance or displacement divided by time. If you able to find your force, you can, and then able to find your distance that you travel and able to find your time that you cover the distance. You substitute this value and you can find the power. Okay, so I gave you some outline, and the next video I will discuss more about this. Thank you very much.